morning, good afternoon, good evening, wherever you are. Welcome. Thanks for joining this session. My name is Venkat Raghavan. I'm the founder and CEO of Stack Identity. I'm working closely with the CSA for a number of months now. This is a very interesting topic today, how to transform your cloud IAM processes to address the zero trust issues created by shadow access. So let's dig right into it. The context and the backdrop for this session is the latest research from the CSA on shadow access. Shadow access is a new problem. The CSA has defined this as an emerging IAM security challenge. It is part of the IAM working group. This report was released on September 16th. You can go look at it, but this is the context and the backdrop for how I'm talking about shadow access as a new problem and its implications for zero trust, as well as the IAM processes. The agenda for today, I'll give a quick introduction to shadow access. We'll look at ways to detect shadow access, introduction to IAM and identity security. They are two different terms. We'll talk about shadow access, the implications for zero trust. We will discuss the cloud IAM and the zero trust blind spots from shadow access, and finally a call to action. Let's start with what is shadow access. Shadow access is a phenomena created by the proliferation of tens of thousands of entitlements in the cloud environments. This creates invisible and weaponized pathways for attackers. Shadow access lives in many systems today. It lives in your identity systems, your access control systems, your database systems, your data platform systems. And essentially, shadow access, for the most part, creates unauthorized, unmonitored, invisible, and unintended access to cloud data, applications, and software. It is an urgent problem because shadow access is legitimate access. It is a legitimate entitlement that in the wrong hands can lead to a data breach or a security incident. What causes shadow access? Today, we're seeing identities are often created and they live in multiple ecosystems. Your identities live in Okta, in Azure AD, in Active Directory, in AWS, in GCP, in Snowflake, in applications like Jenkins. There are lots of areas in which identities should live in the cloud environments. Second, access credentials also live across multiple systems, are used in a large variety of contexts. Now, developers use these entitlements to connect cloud services to data and applications. And why is that? Because identity and entitlements are the cornerstone of modern cloud security. So developers use these cloud services, they combine these entitlements, and in the process, they create overly permissioned environments. Now, generally, developers think of security as a friction point, and developers are motivated by pushing new builds in an automated fashion. So their focus is less on permissions and more on speed and agility. And therefore, most cloud environments are generally over permissioned, resulting in lots of shadow access. Why does shadow access matter? But fundamentally, shadow access creates blind spots to your IAM processes and whatnot. And in the cloud, it's very different compared to your on-prem world. In the cloud, lots of these actors who have identities are actually non-human. Only less than 5% of the identities are human identities. And these non-human identities, which make up a majority of the identities of the cloud platforms, are attached to your cloud services, your APIs, your infrastructure, and third-party access and whatnot. So there is a very different world we live in terms of the environment in which the cloud lives in. Therefore, shadow access is very easy to be created. You generally live in an over-permission environment. A lot of automation creates shadow access, and that creates massive security blind spots as well. Now, why is it difficult? It's difficult because there's no single console to go look up shadow access. You cannot go to the AWS console and say, show me all the shadow access. It doesn't happen. And it's quite difficult to see because you can acquire shadow access through programmatic access. If you are an identity, you can elevate your own permissions through shadow access. So fundamentally, shadow access is difficult to see and very easy to exploit. And that makes it a dangerous combination. And it makes it very easy for attackers to grab an entitlement that is legitimate and laterally move across the organization They get to the data and start to exfiltrate data, or actually downright to conduct data breaches or ransomware attacks. We call this phenomenon toxic combination. When developers combine cloud services, they're actually creating, in many cases, toxic combinations. But the entitlements across two different services creates a toxic combination, which in turn creates unauthorized and invisible access pathways for attackers to breach your environments. So primarily, we are talking about a new concept of shadow access calling breach pathways, that through these combinations of access, which are toxic, attackers can start at a very legitimate, safe point and work their way through the organization and to get to the target, which could be a data store or a supply chain or a software, and start to do exfiltration. And to just give you a sense of the scale alone, AWS alone has got more than 15,000 permissions and growing. So even if you're a 10% AWS shop, you're looking at millions of entitlements you're going to deal with, and the toxic combinations that it creates. Now let's dive into how do we detect shadow access. Working with the CSA group, we've identified 10 different types of shadow access. Very similar to the OWASP top 10, you can think of this as the top 10 shadow access patterns. And they generally go like this. They're invisible access, access given through programmatic access, you cannot see it, unwanted access, excessive access, dormant access. This is usually the case in cloud environments. People spin up projects, give access, and then walk away, dealing with a lot of dormant access. Cross-account access, especially as people are sharing data across cloud accounts and across regions, cross-account access becomes a huge issue. Data recovery access, the type of access that is targeting your IDP systems, your Oktas, your KMS systems, highly risky access, and whereby the attackers can get a hold of the keys to the kingdom. Risky access, toxic combinations, unused data. In the cloud, it's very simple to spin up a MongoDB in 30 seconds, copy sensitive data, work on a project, and then go away, leaving lots of shadow data behind this and access to it. Huge problem. And lastly, ability for us to right-size access is also a big part of this. So the first thing is to detect the access, and the second thing is to right-size the access. Now, fortunately, we have a lot of the out-of-the-box policies to help track and monitor your shadow access. And you can think of shadow access as entitlements attached to two different things. Entitlements attached to your cloud environments. In this case, we can track risky identities. You can enable these policies to help you track risky identities, risky policies, IAM configuration changes, identities without service tickets, identities that can privilege escalate themselves, dormant access, for example, access not used in 90 days, unused access, rarely used access. Again, these are examples of access given at one point in time for a legitimate reason, but should have been revoked and never has been revoked. So it becomes an exception or rarely used access. Over-permissioned access, dormant access that breaks your SOX and FedRAMP compliance. Policy drift in third-party access. Increasingly, every SaaS application wants to connect your data, creating the proliferation of third-party access. So all these are entitlements attached to your cloud infrastructure environments that create shadow access. Then we have a whole dimension of entitlements attached to your data systems. When I say data, I mean things like in tables and unstructured data, columns, rows, tables, schema objects, and things like the data that resides into your S3 buckets, or Azure Blob, RDS, DynamoDB, SQL Server, Snowflake, BigQuery, et cetera, et cetera. How do you correlate these identities with SSO? Many times these are local identities that are not under an SSO, so they live inside the database and create shadow access and shadow identities problems. Some of them expose sensitive data. It's very difficult to track shadow access and entitlements to these sensitive data assets, and especially admin access to sensitive data. When was the last time we reviewed the access? The third-party access. There are new concepts like data sharing, which is exploding in the cloud, especially with platforms like Snowflake. How do you track data sharing across your cloud accounts and across your various identities and regions? Dormant access to PCI data sets. So all these are entitlements that somebody has to go track from a security perspective, from a compliance perspective, a risk and a governance perspective. Now let's talk about identity and access management versus identity security. So we all know identity and access management. We all are familiar with Active Directory, which was the foundation for many, many enterprises. Single source of truth of identities, everything built around the Active Directory, centralized. Life was great. Now the cloud showed up, and now you have a number of identities in all over the place. You have identities living in your IDP systems like Okta or Azure AD or Google IAM or AWS IAM. You have identities residing in Jenkins, in your GitHub, in your databases like MongoDB and CI/CD pipelines. So we have now gone from a centralized model to a decentralized model. And that's a very different way to understand. So the world we live in is massive level of decentralization and distributed systems where identities and access and entitlements are all over the place. Now let's look at the process changes. How is an IAM process different from an identity security process? Let's discuss a bit. The typical IAM process started off as an IT function. It's the IT productivity function. For IAM process, it's mostly concerned with users. Identity was never a foundation of an IAM process. It was mostly focused on users. As we discussed, the operation of IAM was mostly centralized. And any type of review process or governance process was mostly backward-looking from an IAM perspective. Governance was strong because everything was centralized. You had to go through a single place to get approvals and whatnot. That was great. Environment is on-prem, maybe one IDP, like Active Directory, maybe one more. IAM processes conventionally didn't worry about context. They didn't worry about users and behaviors and anomalies. That wasn't their focus. Certainly, they were not data aware. They were not threat or vulnerability aware. They were focused pretty much on compliance and no concept of risk as well, and primarily human or user-centric. Now, the identity security process is a very different dimension. Its focus primarily is on security. What is the role of identity from a security perspective? And why is that? Because identity is now the foundation of modern cloud security. You cannot spin up anything in the cloud without an identity and an entitlement. If you want to spin up an EC2 instance, you need to have an identity. If you want to run a Lambda function, you need an identity. If you want to create a database and have access, you need an identity. Everything in the cloud needs an identity. So now our focus shifted from productivity and operational efficiency from IAM to what are the security implications. The creation of identities in cloud is mostly decentralized. It's created through Terraform and infrastructure as code and CloudFormation templates. The review process for an identity security process is mostly forward-looking. What could happen? What could be breached? Or what are the pathways by which I could be breached? Is the breach imminent? Very forward-looking questions. Governance is extremely weak because we prioritize in the cloud automation for governance. So governance is extremely weak, and that's why we see shadow access proliferating. The environment in the cloud is mostly multi-cloud. People have AWS and Azure and GCP or private clouds like Kubernetes, and also multiple IDPs. They have an Azure AD, they could have an Okta or a Jump Cloud, they could have other types of systems. So it's all over the place. And clearly, the activities of users and identities are crucial here in this case of identity security process. They must be data aware, for sure, because we live in the area of generative AI, because everything wants access to your data. So all the APIs want to connect your data systems. They want to create, read, write, delete, export, download data. This is a big problem. Of course, a process of identity security has to be well aware of our threats and vulnerabilities. And of course, it's going to be compliance-centric, risk-focused, and primarily it's going to be non-human-centric. These are the big differences between an IAM world we used to live in and the new world of identity security process. Now let's look at shadow access and implications on zero trust, which is the primary topic of this session. So what is zero trust? You've had a number of sessions that to give you a basic definition. It's never trust, always verify. Very simple definition. Now, fundamentally, if you look at the shadow access problem at a very basic level, shadow access undermines zero trust. Why is that? Because of lack of governance, as I talked about. Many cases, the identities and entitlements are getting into the cloud environments through automation, through Terraform, through infrastructure as code, through tools like CloudFormation template. So there is no accurate view or complete inventory of identities in the cloud environments, and mostly they are non-human. So at a very fundamental level, if you don't really understand who should be in your cloud environments, that's already a massive gap in terms of security and compliance. So that fundamentally undermines zero trust. The second big issue is the identity set up properly? Is the identity properly configured? For example, like for multi-factor authentication, is there an admin account What is the type of privileges for this account? And things like that. So there's lots of focus on, is identity set up in the right way? So the combination of, do I have the right identities in the cloud? Plus, am I set up the right way? These are basic questions to answer for zero trust. But unfortunately, processes today don't answer these questions. And that at a basic level undermines zero trust. Let's take some very common examples of shadow access that break zero trust. The first is excessive access. Many times developers create identities through Terraform, and they have lots of access because they view security as a friction point, and they like to get the maximum access possible. And so they essentially provision accounts with a highly permissioned environments because the governance is very loose. Second is most of the permissions assigned for cloud environments are actually long-standing privileges. They're never used. When we discover shadow access patterns, we see a number of cases of unused access, and dormant access issued for the 6 months not being used. And again, rarely used access, people giving exception-based access to production systems, but not cleaning it up. Lots of abnormal, unusual, anomalous, suspicious access. Why? Because of APIs. The majority of the identities in the cloud are non-human. So they're using automated APIs to connect to environments. And a lot of times attackers do enumerations. So you're seeing a lot of abnormal activities, repeated authorization failures. These are all conditions that create anomalies and suspicious activities. A big, easy problem to fix is widely scoped access, /star access. And so this is a real problem where an identity has got explosive access to everything, every resource on the cloud. And this is the power of the cloud. If you have this permission type, then if an attacker is going to get hold of this role that gives them the wider scope, they can access any resource on the cloud. Anything that violates the principle of least privilege, for example, if there is a case where you're actually using roles and you have a set of commonly defined roles, yet you have unused permissions or rarely used permissions in these roles, it means that you have commonly used roles that are a lot of exceptions built in that violates the principles of least privilege. Vulnerabilities, for example. A lot of times we are seeing tools, vulnerability management tools, have vulnerabilities, they detect 0 days, but they're essentially in a cloud. Those initial vulnerabilities, the initial access results in an exploitable pathway, a lateral movement according to the MITRE framework where they can get to the data. Access drift. This is the common case where access is given. Now it's accumulated, it's drifted from the original intention. That creates a lot of shadow access. So all these are very day-to-day examples, practical examples of shadow access that break zero trust. So how do you transform the cloud IAM to eliminate zero trust blind spots? So this is the topic that really is the last part of the session. So let's look at the problem from various perspectives. If we look at zero trust, one of the primary focus of zero trust is to really make sure and ensure that environments operated with least privilege enforcement and zero trust principles. So least privilege is a very concrete principle that zero trust architectures adopt. And that means if you're not operating in least privilege, there's more unnecessary privileges that actually violates the principles of zero trust. And that's exactly the root principle of shadow access. You should just have the right level of access for the right level of people for the right reasons and for the right duration, nothing more, nothing less. Anything outside of shadow access. So we can agree that zero trust and shadow access intersect, and they're both maniacally focused on least privilege enforcement. Now in the cloud, the question is, how do I adapt the cloud environment? How do I adapt the IAM in the cloud environment to focus on these? How do I operate in zero trust in the cloud environment? And that means we need to think about a few areas the conventional IAM doesn't think about. First, you should think about the security focus. The cloud is very dynamic, very automated through CI/CD pipelines and infrastructure as code and whatnot. And primarily the actors in the cloud are non-human identities. So how do we now start to think about these dimensions of security, automation, IAC, and non-human identities in terms of implementing a state of operating in least privileged mode? Now, fortunately, if you look at NIST 800-207, Zero Trust Architecture Specification, it talks about this extensively. It talks about the need for a continuous diagnostic and mitigation applied to IAM processes, especially to cloud IAM processes. So we can learn from this process. We can learn about this. We can start to think about, hey, we have all these IAM processes today. We have an authentication process or authn. We have an authorization process, or AuthZ. We have a data security process. We have an identity and access governance process. But all these processes suffer because they're not implementing least privileged policies. There are gaps to least privileged policies. And why is that? Because of shadow access. So we need a new layer of continuous diagnostic and monitoring applied to cloud IAM processes. And that's the purple box here. The yellow box is the least privileged monitoring box. That actually allows you to minimize the uncertainty in enforcing least privilege per request access decisions to improve zero trust. Just to give you an example, the authentication process must be much more smarter to deal with identity and security vulnerabilities as the authentication happens. Your authorization process must be smart to know what are the policies for the users that are violating least privilege right there, and be able to take some action around it. For example, automatically deny access to dormant policies and re-request you have the user request a new certification for access. Data security, if there's a policy that violates and provides pathways to the data, then we could have some sort of a second factor authentication to kick in, or put the request in an exception queue for processing. But the most fundamental broken process is identity and access governance. We all know about access reviews, and access review is a very core process of conventional IAM. Every company does access reviews on a quarterly basis. You have a checklist of access to be reviewed. You send it to the managers. They blindly approve the access because it's quite difficult for them to do it otherwise. But that process is broken for a number of reasons from a zero trust perspective. A, these governance processes do not know how an identity is being used. They do not know how access is being used, how entitlements are being utilized. They do not know how privileges can be elevated or escalated. They do not know what data is at risk. So all of these identity governance processes are blind to these type of actions and activities and risks of identities, entitlements, and access and data. And therefore, the current process is completely broken. This is an example where attaching a least privilege monitoring process to an access review immediately strengthens and fortifies governance for companies as they start to plug the holes of shadow access and start to instrument a more of real-time, continuous, and a risk-based approach to identity access governance and start to remove some of the shadow access problems. What is the call to action? Now that we talked about, shadow access, we talked about IAM, zero trust, we talk about the process gaps. What do? The first thing is start to monitor your IAM activities. You start to look at what's happening in my cloud environments. Who are the actors? Who are the humans, non-humans, the APIs that are touching my data? You can apply some baseline, 30-day monitoring, 60-day monitoring, and 90-day monitoring. You establish a baseline to identify all the shadow access activities. Now that you've identified and got a list of shadow access activities, why are they happening? Is there a policy violation? Is there a policy gap? Is there some aspect of activities that I'm not visible to? So this allows you to understand and discuss how shadow access can occur and take actions. And lastly, once you know why something is happening, why shadow access is happening, then you can start to do remediation of shadow access. That we can take a look at by prioritization of risk and impact. You can start to look at how do I change my policies? How do I redesign my policies? How do I shift left? All these are aspects you do, but it starts with monitoring of your IAM activities, starting to get a hold of all your shadow access gaps. Why is it happening, and how do I ultimately fix it? And how do I design it in the right way so that it works in the future? One example of what Stack Identity, our startup, is pioneering is this approach where you can start to automate the monitoring, detection, and remediation of cloud IAM blind spots. Stack Identity is an early stage startup, Bay Area based. We can automate, provide this automated layer to monitor all the shadow access activities. Our data lake consolidates activities of identities, entitlements, and policies across cloud infrastructures, applications, and data stacks, and gives you visibility to all the risky entitlements that are the root cause of shadow access. We also give you detections that identify policy gaps. These are the gaps you have in your environment, that if you plug these gaps, then you start the process of eliminating shadow access. Lastly, we're able to prioritize the most impactful shadow access so that you can continue to take quick action before this turns into a data breach or a security incident through our patent-pending breach prediction index PPI algorithm. And of course, we cover a whole range of platforms, from all the public cloud platforms to Snowflake, to GitHub, to Okta, Azure AD, Kubernetes, all these environments. So there are technologies today available from Stack and others that allows you to continue to build this process and start to make sure that your IAM processes do not have these gaps of shadow access, they can continue to then plug the gap and essentially continue to operate in zero trust all the time. Next steps, if you want to learn more about shadow access, you can obviously look at the CSA website for the research report on defining shadow access. A great report that came out on September 16th. So you can download a copy. You can look up my profile, and happy to answer any questions and topics. There's also an active CSA working group as well. Lots of great discussions happen into kind of understanding shadow access. The next piece of work is to kind of defining shadow access and the implications for zero trust. So if you have an interest in joining a working group, please join as well. If you want to really do an assessment of shadow access in your environment, then you can go to our website, download our code. You can run this in your own environments. Easy to use. In 10 minutes, you get all the shadow access reports. Get an email. You can start to at least discover and baseline your shadow access. So I want to thank you very much for the opportunity today to talk to you about this. I'm happy to take any questions. You can reach out to me as well at venkat@stackidentity.com. Thank you very much.